The ambiguous case happens only when it's side-side angle. The ambiguous case happens only when it's side-side angle. And the angle has to be pretty, what you guys? Small. To be an ambiguous case, it has to be side-side angle, and the angle has to be pretty small. So, let's say, and don't assume that my triangles are drawn to scale or anything. Let's say we have triangle XYZ. I know this side's 8, I know this side's 9, and I know this angle right here is 20 degrees. This could be the ambiguous case because it is side-side angle, and I made up an angle that was pretty small. Okay? There are a couple of ways of handling the ambiguous case. Some people like to go use law of cosines to handle the ambiguous case. What does law of cosines do to handle the ambiguous case? Well, at some point, you end up in the quadratic formula. Okay? And in the quadratic formula, if you end up with 2 positive answers, it means you end up with 2 triangles. And in the quadratic formula, if one of your answers is positive, but the other answer is negative, then it means you end up with 1 triangle. And if on the rare chance you ended up with 2 negative answers, it would mean there was no triangles. Okay? What you're talking about is handling the ambiguous case using law of sines. So if I were using law of sines to handle the ambiguous case, I would say sine of 20 degrees over 8 equals sine of angle y over 9. And on my calculator, I would take sine of 20, times it by 9, and divide it by 8. And somebody tell me what that is. Sine of 20 degrees.
0.384772661.
Okay, so 0.385, let's just say. Okay? At this moment, you do inverse sine. And your calculator will give you an answer in quadrant 1. And what answer does it give you when you do inverse sine on what you had in the calculator?
22.63.
So 22.6 degrees. Okay? So what do we know right now? We know that we have a triangle with sides of XYZ and angles of XYZ. We know that side Z was 8, and side Y was 9, and angle Y was 20. And we just had a situation where sine of Y was approximately 0.385, and our calculator told us the angle was 22.6 degrees. But our calculator won't tell us about the obtuse angle that also would have its sine being 0.38. At this moment is when you find out for yourself. You do 180 minus whatever angle you just got. And what do you get? What's 180 minus 22.6?
157.4.
157.4. Sabrina, it's this angle that you add to 20. And if it went over 180, there wouldn't be a second possible triangle. If it was under 180, then there is a second triangle. So instantly, you have the ambiguous case. The given information isn't ambiguous. That's going to stay constant. But you've got two possible values. Wait, which was the... Oh no, it was angle Z that was 20, sorry. You've got two possible values of angle Y. You've got the possibility that angle Y is 22.6, but you've also got the possibility that angle Y is 157.4. Only if 157.4 added to the 20-degree angle that was given did not exceed 180. And if you add this up, you get 177.4. So you have, although it's not very big, an angle that's 2.6 degrees. Technically, there's a second triangle because there was enough leftover degrees for it. Okay? That's when you add, so right here, sine's ambiguous. Sine of an angle is 0.385. If you try on your calculator, what sine of 22.6? Your calculator to say 0.385. But if you ask your calculator what sine of 157.4, your calculator will again say it's 0.385. Why? Because sine is positive in quadrants 1 and 2. And so there's therefore both an acute and obtuse angle that has a positive value of sine. And so that's why there's an ambiguous case here. So here's one possible triangle, and then here you just add these two together, subtract from 180, you've got the other one. And then you use law of sines and figure out what angle X would be, what side X would be with this angle versus what would side X be with this angle.